Okay, today we're going to be going over the triangle inequalities. Just share my screen here. Let's see. There we go. Okay. So we're going to be going over the triangle inequalities. So what's interesting about the triangle inequalities is they have a lot of different forms, okay? We're going to go over 4 of those different forms. We're actually going to prove 3 of them. And the 4th one is just going to be kind of an example. Those are going to be, we'll get into it and you'll see what I mean. So the first thing we're going to go over, is going to be, we're going to want to prove that A plus B is greater than C. And that's if you look at a triangle here. So if you look at a triangle, A, B, C, you can see kind of by just example that it's pretty obvious that A plus B is going to be greater than C. And by the way, it's the same thing as saying, you know, B plus C greater than A, or, you know, B plus C, or B plus, or C plus A is greater than B. Those are the same thing. It's all kind of, that all means the same thing. It's all arbitrary. Okay, so you kind of see that, notice what A plus B means here. So let me actually put it in the right form here. We know that if you look at A and B, oh, that's what they're wrong. Okay. Let me just do that one time. So we have A, B, C, besides A, B, and C. So you can see that A here is A, if you add A and B together, okay, let's say B is of length 1 and A is of length 1, okay, then A plus B is going to equal 2. And so there's no way for C being a straight line is ever going to be, you know, less than or greater than 2. So C has to be less than 2 based on A equaling 1 and B equaling 1, because we have this space right here. This space is kind of like the least, it's a greater travel. If you look at from this side to this side, you're actually doing the quickest travel with C. So obviously any other travel you do, because it's not a direct line, it's not equals I kind of a thing, you're always going to get a bigger line. But we're going to prove that. So now we're going to prove it. Okay. So before we prove it, I'm going to go over the other things we're going to talk about. Other things, so we have, we're going to prove that. We're also going to prove the absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. So we're also going to prove this. then we're going to actually use 2 to prove the next one, which is going to be the absolute value of the absolute value of x minus the absolute value of y less than or equal to x minus y. Absolute value of x minus y. We're actually going to use 2 to prove 3. Now, the last thing we're going to go over, we're not going to prove this, but we are going to go over it, is this vector, which is the absolute value of the vectors x dot product of y less or equal to the absolute value of the absolute value of x, or not the absolute value of the dot product. Kind of weirdly done here, but we're just going to kind of show that this part is true. Okay, so moving on to our first proof. Okay, so proof A plus B is greater than C. Okay, so first, here A plus B is less than C. Well, I mean greater than C. Greater than C. Proof. First, we're going to let ABC be the given triangle. So we're going to let it be the given triangle here. Now, notice this is kind of different than what we've shown here. Back here, I was using A, B, and C as the sides to kind of give a point, but now I'm giving the actual points, the letters. So it's, you'll see what that's going to do. We're actually going to use these points, okay? And so what that means is now what we want is, so this is not the same thing. I might even give these miniature levels, miniature letters, just to show that it's not the same thing. We actually want AB plus AC. Oh, change this. Want AB plus AC greater than BC. So it's the same thing, but it's just using the points instead of the lines. So the 2 points, you see A and B, A and C, B and C. Okay. Now, we're going to then let the bisector, so we're going to bisect this triangle. So actually, if I bring this out and I make this bigger, here we go. I'll just copy this. bigger over here. So that this can be stop there. Okay. We're actually going to be able to bisect this thing. Because, let's see, as every angle has a unique bisector, we're going to let the bisector of angle A meet the line BC at D. And we're going to make a new point D. New point D. Which is going to have the same length for those two. So now that, so B, the angle BAD is going to be equal to the angle CAD. Okay? And then, and now by definition of bisector. Now, we have that in place. Now, angle ADB is greater than angle CAD. And notice that the reason this is the case is because the exterior angle is greater than the interior angle. So notice this exterior angle is going to be always greater than the interior angles. That's just by definition. So we know that angle ADB is going to be greater than angle CAD, which is this angle. So this angle can be greater than this angle. Okay. And by the same thought, angle ADC is actually going to be greater than angle BAD. Okay. Now, I'm going to make this different color so it doesn't confuse. Make that black. Okay. So now we have two different angles that are bigger than the others. So if that's the case, and that's because of the exterior angle, because of the exterior angles, then AB is greater than BD, right? AB is actually going to be greater than BD. And that's because if two angles are unequal, so this is another property. If two angles are unequal, okay, or if this angle over here, ADB, if this angle's bigger than this angle, then in the same way, the opposite side is going to be bigger than the other one. So this opposite side here, so if we look, give us a color here, this angle goes to here, this angle goes to here. Or I should say, see, BD, which is the same, and this, and remember DC, note, is equal to BD. Because bisector, that's the definition of bisector. So, which means that AB is going to actually be bigger than BD. Okay, that's where that comes from. And this is by the same logic, AC is going to be greater than CD, which is AC right here is going to be greater than DC, or CD right there. Okay. Now, if we add this and this with this and this, we can get the same thing, but mix them together. Get AB plus AC is greater than BD plus CD. And we know that BD and plus CD is just BC. So AB plus AC is greater than BC. And that concludes the first proof. Okay. Here we go. Okay. I now quickly want to show you what is not going to be a proof, but just to kind of give you an overview of, kind of help you out with what this is really saying. And vectors is the best way to do it. So remember what I was saying about before. So kind of a side cape here. And, yeah. So we have X dot y less than or equal to okay. We're going to look at this geometrically. So let's say we have a vector here. So we have a triangle. Now you can look at this in a different light. That's what we're going to do this time. Okay, so let's say I have a vector here. And we have another length here. And then so we have, actually let me do this a little better. We have angle A, B down here. So that means that if we add A plus B, we actually can put the two vectors together, and this is the magic here. So if I copy this and actually bring it, actually I'll copy just this part. If I actually bring it over here, it actually becomes, this line right here becomes A plus B. So that is very cool. So it's to do with vectors. And that is why you obviously cannot have C from the original part here. Where do we have that? Right here. That's why you cannot have C less than A plus B. As you can see, it's not possible because of this. It actually adds up. You have the B and the A here, if you want to do the A again. bird's eye view with this blue line right here. Okay, so moving on. So I thought that was really cool. Okay. Moving on to number 2. Actually, we'll put this down here. Okay. Number 2. So with this, we're trying to prove that A plus B less than or equal to A, that's the value of A, that's the value of B. Okay. So we're trying to prove absolute value of A plus absolute value of B. And how we're going to start this is by giving a slight goal here. We're going to give a little goal. The goal is to prove that the absolute value of A plus absolute value of B squared is greater or equal to A plus B squared. And note that for all x is equal to the rate r x squared equal to x squared. Okay. So that's we're noting that that we have the absolute x squared, which is equal to x squared. So we're going to use it in our proof. Okay, so in the proof, I'll forget. Get for all A, B inside the reals, absolute value of A plus the absolute value of B squared is equal to the absolute value of A squared plus 2 A absolute value of A times absolute value of B plus absolute value of B squared. And that just comes straight from the definition of this using like FOIL, whatever you want to call it. It's straight from that. Straight from like just factoring it out. Which is going to be equal to A squared, because that's why I noted this right here. A squared plus 2AB plus B squared. Again, same thing. Which is going to be greater or equal to A squared plus 2AB plus B squared. Notice that I'm just saying greater or equal to, so we take out the absolute values. And that's because I could give that another note. Also note that, put this down a little further. So note that absolute value of x is greater or equal to x. Same thing. So we're going to use that property for there. Okay. Which then is going to be equal to A plus B squared, which is equal to the absolute value of A plus B squared. Notice using this property, just backwards. And then, okay, and then let's use the same property backwards. absolute value of A plus the absolute value of B squared is greater or equal to A plus B. And that we just proved from that whole above process. This whole thing right here proves this part. Okay. And so then absolute value of A plus the absolute value of B. And notice, by the way, our goal we already met right here. That was our goal. So we already met that. And so it just not very far off from here. We just have to take those squared away on both sides. A plus B, and then thus just switching it around, we have A plus B. Notice that comes from there. A plus B is plus or equal to, switching around A plus B, and we got our proof done. Okay. Now, lastly, for 3. And remember, we're actually going to use that this is the case. So I'm actually going to copy this and bring it down here for our little consumption here. So that will be kind of a note. We can turn this into a note. I'll write a note here. We're going to need that to prove this part here. We're trying to prove that the absolute value of the absolute value of x minus the absolute value of y is less than or equal to the absolute value of x minus y. So that's what we're trying to prove. It's a little bit nicer. Okay. Proof. Absolute value of x. We're going to start out easy here. It's going to equal to the absolute value of x plus 0. Okay. So really, I don't want to show that part, but I just wanted to show that because how I'm going to get to this part here is basically we're taking 0, we're changing it to negative y plus y. And then we're going to use that. And we're going to realize that also we're going to use the fact that this is equal to the value of x minus y plus y. So we're literally saying that the same thing is equal to the same thing. So don't, that's also going to be important. And now we're going to let A equal x minus y and B equal to y. So now changing this will become A plus B is equal to A plus B. Nothing too special yet. Now this is where the second proof comes in. My second proof. A plus B is actually less or equal to A plus absolute B. Now, how are we going to use this? We're going to change it back into absolute of x minus y plus y. Notice we're just changing from this substitution, substituting is less or equal to the absolute value of x minus y plus the absolute value of y. Again, just substituting back. Everything's substitution right now. And this is going to equal x. Notice that that comes from here. That's why I set that up here. Because we're just taking out the y and the y. That's going to be lesser equal to lesser equal to x minus y plus y. And we have, we're going to subtract y from both sides to get absolute value of x minus absolute value of y. X minus y plus y minus y. So notice this got even smaller. Okay, and we're completely fine. We're just subtracting y on both sides. And then we're going to keep the left-hand side the same. And notice that over here we have just x minus y. That's x minus y. We are very close to the end here. Remember, we were just trying to prove. The absolute value of x minus y is less or equal to x minus y. The only thing we're missing here is these other absolute value symbols. And how we're going to do that is we're just going to go with likewise here. So in the same way, we're going to do it the exact same way on the opposite spectrum. So likewise. Y, the absolute value of y is equal to y minus x plus x. It's the same thing. We're just doing literally the same thing we did before. Y minus x plus x plus a value less or equal to x y plus x. So absolute value of y minus absolute value of x greater or less than or equal to x minus y. Notice we just did the exact same thing, and now look at this. We have this part is absolute value of x minus absolute value of y, that's equal to x minus y, and then we have y minus x. So thus absolute value of the absolute value of x minus absolute value of y is less or equal to x minus y. That's value. And we finished all the proofs. There's the beauty of that proof. We have number 2 and number 1. Thank you, and hopefully you enjoyed this.